This lesson is on creating polynomial equations. The connection between the zeros of a polynomial and its factors should be clear by now. This connection can be used to create equations of polynomials. The key to utilizing the factored form of a polynomial. The multiplicity of a root, so that's how many times the root occurs, and likewise, the exponent on the factor can be used to determine the behavior of the graph at that zero. So if the multiplicity is odd, the graph will cross the x-axis at the zero. That is, it will change sides or be on the opposite side of the x-axis. If the multiplicity is even, the graph will touch the x-axis at that zero. That is, it will stay on the same side of the x-axis. So we have a couple examples at the bottom. So the first one, we have x plus 3. Notice the exponent is 1. We know the root is negative 3 because it's the opposite of the factor. And when you look at the graph, it crosses the x-axis at negative 3. And notice it passes through that root. All right, and that's because, again, it is opposite. So opposite is a pass-through or a cross. All right. In the next one, we have x minus 1, and it's raised to the third power. We know the root is 1, and its multiplicity is 3. In parentheses, it says the higher the odd degree, the flatter the squiggle. So you can see at that root of 1 how it flattens out, okay? But notice it passes through that root, just like the previous example. Now we've got some even ones. So x squared, I rewrote it so it looked more in factored form, I guess, if that's what you want to call it. So x minus 0 squared is the same as x squared. So we know our root is 0. Now, though, we have an even multiplicity, so it touches it and bounces back up. So you could call it a touch or a bounce. And so you can see it comes down at 0 and then goes back up. It doesn't go through to the other side. All right. And the last one, oops, I have a typo. It should say x plus 4 to the 4th. Therefore, the root is negative 4. The multiplicity in this case is also 4. So again, the higher the even degree, the flatter the bounce. So you can see at negative 4, it bounces just like the previous one, but because the multiplicity is higher, it's flatter longer. I hope that makes sense. So it's really important that you know when it goes through and when it touches or bounces. Okay, so it's a touch or bounce. It's a cross or through. All right, so let's do some examples. Let's write some equations. So exercise 1. Determine the equation of a quadratic function whose roots are negative 3 and 4 and passes through the point 2, negative 50. Express your answer in standard form, so that's really important that you understand what standard form is, and they told us it was a quadratic. Verify your answer by creating a sketch of the function on the axes below. So the first things, what do we know? Well, we know the roots are negative 3 and 4, so we know that x equals negative 3 and x equals 4. Well, if we know that x equals negative 3, we know the factor is x plus 3, and we know the factor is x minus 4. So these are the roots, these are the factors. We know that relationship, and if we don't, we better quickly learn it. We also have this point 2, negative 50, and that represents our x and y. So when we write equations, we have y equals, so negative 50 equals, and we have this a value, and we've talked about what a is. A is that stretch, compress, reflect thing, in the transformation. So we have to find our a value, and we're going to take that a and multiply it by all its factors. So in this case, it's a quadratic, so there's 2 factors. The multiplicity of those factors, or the roots, are 1 each, so they don't repeat, which means we also know that since the multiplicity is odd, they go through those roots, okay? All right, so let's do our math. So we need to multiply these 2 things. So whether you use the box or you just double distribute, it does not matter which method you use, as long as you do it correct. So I have a times x squared. Oops, I'm such a goof. Reverse all that and ignore me. If I know y is negative 50, I also know x is 2. Oh, such a goof. So I have x, which is 2. So I now have negative 50 equals a 5 times negative 2. Sometimes I lose it, sorry. So that is a negative 10, so I'm going to divide by negative 10. So 5 is my a value. So here comes the hard part, and I wasted all my space over there. I have to write the equation in standard form. So again, y equals, I know my a value is 5, so 5 times x plus 3 times x minus 4. So see, I was getting ahead. I do need this for the standard form. This form is called factored form. Sometimes the questions will say that, sometimes they won't. If it's a multiple choice, you can just graph it and match them. So I know that this is x squared minus x minus 12. Y equals. So therefore my answer is y equals 5x squared minus 5x minus 60. And I could multiply that on my own. So that is the standard form of that equation. And remember, standard form doesn't tell us very much. It tells us our y-intercept is negative 60. But that's it. Okay? Factored form tells us so much more. So we have a root at negative 3 and a root at positive 4. We know, again, our y-intercept is negative 60, and it's going to be not the turning point. The turning point has to be between these, somewhere at 1. Okay? If you want to find the turning point, you just put in 0, or in this case, you put in 1 here. So we have 5 minus 5. So 5 minus 5. Interesting. All right, well, let me graph it just to make sure. Hopefully you were thinking, Duffer Letty, in between these, this is a half. So the turning point is at 0.5. And it is negative 61.25, so you could plug a half in and find that, or you know it's got to be below 60. Okay, so our graph looks something like this. Ooh, that was terrible, I missed. So make sure you hit that point, okay? How do we know it goes this way and isn't negative, or isn't sad? Because the a value isn't negative. Remember, that's a reflection. But notice, again, 2 ideas in this lesson. It has the roots, the multiplicity is 1, so it goes through. And 2, how to write the equation. Okay? All right, why don't you pause the video and try exercise 2, using exercise 1 as your model. All right, let's go through this one. Hopefully you have the same answer. They told us 1 root or 0 is negative 3, so I knew my factor was x plus 3. Turning point or the vertex is negative 1, negative 16. So when I sketched those over to the right, they didn't tell me the other root, but I know it's a quadratic, so it has to have 2 of them. And they didn't tell me that negative 3 had a multiplicity of 2 or anything like that, so I've got to use my brain. Well, I need to know that the distance between the 0 and the turning point has to be the same on both sides. It's the line of symmetry in your parabola. So, since I know my root is at -3, and I know my turning point is at -1, that distance is 2. So I have to go 2 more to the right to find my other 0, or root. So that helps me find this other 0, which helps me find the other factor, which then I can plug it in and find my a of 4. And then I can do my math, factored form, standard form. I can sketch a graph here. Hopefully this time will be better. And there we go. Okay? All right, let's look at the next page. We are going to do the exact same thing, except now we're doing this to higher powered. So in this first example, it's a cubic, and it says factored form. And then down here is a cubic in standard form. Oh, fun, fun. So the first one, create a cubic in factored form, and it has its x-intercepts. And it passes through a point, just any random point. All right. So we know that that gives us x equals -4, x equals 2, and x equals 5. And we have the point 620, which represents my x and y. This gives me a factored form of x plus 4, x minus 2, and x minus 5. And I have to find that stretch or compress that a value. So y is 20 equals a. X plus 4, well, x is 6, so 6 plus 4, 6 minus 2, and 6 minus 5. So I'm going to go ahead and do that math. So 20 equals a times 40 divided by 40. So a is 1/2. So now I know y equals 1/2. To compress, x plus 4, x minus 2, and x minus 5. And there is my factored form. So now I'm going to go and graph. So -4 is one of my roots, 2 is another root, and 5 is another root. I know since they're all multiplicity of 1, it has to go through those points. Because a is positive, I know it has to end positively. So believe it or not, I know that it has to start down here like this, and it has to end up like this. Okay? Now, since I'm just kind of sketching it, I'm not going to be as specific. So it looks something like this. All right. If I was using an actual piece of graph paper, I probably should be a little bit more specific on some of those points, especially the y-intercept. Okay, and so the max and the mins, I should be more specific too. All right. So yes, I want you to try exercise 4. Notice it says that you have a double 0, which means a multiplicity of 2. So that means on that factor, you're going to have a power of 2. All right. So that means we have multiplicity of 2 on 0, so x equals 0. So that means you have x squared because it's a multiplicity of 2. A double 0 at -2, sorry. So x equals -2, so x plus 2 is squared. And another one at 4, so x equals 4, so we have x minus 4. And it says a y-intercept of 16, so we know that point is 0, 16, which represents our x and y. So why don't you pause the video and go at it. And when you're ready, start again. Please don't forget that you need to do this in standard form, so you need to keep going on this multiply. Okay? All right, good luck, and continue when you're ready. All right, so hopefully you got -x to the third plus 12x plus 16. I started the graph based on what I know. Since at -2 it is squared, that means it's a bounce or a touch. So it goes to that and goes back up. And at 4, it goes through because it's a multiplicity of 1. How did I know which way? Well, because A is negative, remember this is a reflection, so that means it has to have a negative end behavior, which we're going to start to talk about. So if it's ending negative, it needs to look something like this positively. I know it's going through positive 16. So something like that. Okay, that looks kind of weird, but you get the point. Okay, I know that this is at 16 because that's my C value. All right, so now let's look at this last example. Now we're going to talk more about vocab again. Vocab is very important when we talk about polynomials. So we have this equation in A. They are asking us to find the zeros, the multiplicity, and whether it crosses or touches. The first thing we're going to look at is the zeros. This doesn't give us any zero, so this gives us a zero of 1 because it was x minus 1. And then x plus 3 gives us a 0 of negative 3. Multiplicity is the power, or the exponent. So the exponent on x minus 1 is 1. The exponent on x plus 3 is 2. Does it cross or does it touch? Well, we know that an odd multiplicity means it goes through, so it crosses it. And we know a multiplicity that is even touches it, or sometimes we call that the bounce. Right? What is our y-intercept? Well, with a y-intercept, we know that x equals 0. So y equals 5 times 0 minus 1 times 0 plus 3 squared. So that's 9 times negative 1 is negative 9 times 5 is negative 45. You can absolutely use your calculators. What is our degree? Well, our degree comes from adding our multiplicities. So our degree is 3. So you don't want to do end behavior till you graph. So we know that the zeros are at 1 and at negative 3. We know that it crosses through, and we know that it touches or bounces here. And we know it goes through here. It's a positive A value. And we know it goes through negative 45. So I'm going to call this negative 50, negative 100, positive 100. So negative 45 is right around in here. So it goes something like this. Okay. So our end behavior, how we're going to notice our end behavior is always to the right, and it is positive or increasing, and we are going to write it as how do we want to write this? X approaches positive infinity, so x is going this way. What is happening to f of x? F of x is approaching positive infinity. It's going up. Okay, hope that makes sense. All right, so I guess we're done. Good luck. Oh, my graph is off. Sorry. So good luck. If you have any questions, please don't hesitate to ask. This is a lot of vocabulary, so really soak it in.